Hello everyone, George here, and we are looking at the second half of Chapter 2 in the Game Programming in C++ book today. The second half of the book is all about adding sprites using the component system that we had started to set up in the first half of the chapter. Now, if you saw the prior video, then you know that instead of using components, I opted to just create different actors that inherited draw functionality. Now, during the second half, we are going to take all that functionality, specifically the rendering of sprites or textures, tear it out of our actor classes and throw it into a separate component class. And there's actually going to be 3 different component classes that we're going to be creating. A general sprite component, which is going to handle drawing a texture on the screen. We are then going to create an animated sprite component, which allows you to swap between different sprite textures that you store. And then finally, a background sprite, which will move across the screen slowly. Everything that I'm going to talk about is definitely squarely in the intermediate area of C++ programming. If you do not have a firm grasp of the basics and you're not confident in being able to look things up yourself or debug quite a lot of errors, and sometimes cryptic errors, you're going to run into a really bad time. So let's go ahead and dive into the code. So let's start with Chapter 2 CPP. In the last video, I had created all the different actors inside of this part of my code, inside of int main. However, what we do now is we take all that code and actually stick it inside of game instead. So this means that our entry point into our application is incredibly simple. So we create an instance of game as usual, check if it's successful, we run our loop and our shutdown. And this code doesn't need to be any more complicated than that. Now, jumping into game, a couple new methods were added to our class. You can see that we now have setup texture and load texture. Load texture does all the SDL work of grabbing a file name, loading a surface, converting that surface into a texture. Setup texture is an extra function that I added on top of things just to do a little bit more checking to make sure that everything's okay. The add sprite function keeps a list of all the sprites in our scene so that we can draw them at the appropriate time. Here's the function load data. This is where all the heavy lifting goes. This is where everything that makes our game unique is going to be put, and we'll take a look at that in just one second. The last 2 items of interest are a map of all the different textures so that we can refer to any particular texture by its name, the file path that we happen to use. And then the second part is a vector of sprite components. These are going to be kept automatically ordered for us. So all we have to do is iterate through this list at the drawing time, and it will draw each one using the painter's algorithm, which, as you know, means you paint the background elements first, all the way up to the foreground elements. Why don't we take a look at load data in the CPP file? So right here, you're going to notice that this is a big method, right? And that's because it is setting everything up. Exactly the same code for the most part from the last video. This part is new, however. And now we have a character pointer to a file path. And this is a series of graphics that I created very quickly in Photoshop. So here are some of those graphics. So what we can see here is we've got 3 different ball graphics of the ball getting smaller and smaller. So the idea is that it will pulse so I can show off animation. This is one of our paddles. Here's the other paddle. And then we have 2 different backgrounds of a starry landscape. This one with some sort of a nebula and the other one with just some basic stars. And the idea is that this will scroll over through time. And then we have just a little alternating pattern of different colors for the walls at the top and the bottom. So this is where things start to change up from the last video. Now we have sprite components, which are going to handle all the drawing and the storage of the textures. Here we can see we create a sprite component, we tell it what actor it belongs to, and then we say what order it is when it draws. The lower the ordering, the sooner it draws. The higher the ordering, the later it draws, which means it will be drawn on top of anything that already existed on that buffer. And we have to go through the process of not only assigning the texture to each of these, now we have to go through the process of setting the texture for each sprite. And then we also need to deal with the fact that the actor itself needs to be added to the list of existing actors. Now we do not need to directly add the sprite component to the actor. By passing the actor to the sprite, when we go into its constructor, what we'll see is that we automatically have ourselves attached to it. So that reference gets created and we don't have to do any more assignment ourselves and try to keep track of things. Do the same thing for the bottom wall, pretty much the same code as we saw before. The paddles are very similar. We load our textures up, we go ahead and set up our textures, and we set our offsets. The balls are pretty interesting. I've created 3 different file paths, one for each of those PNGs. This, yes, could have been an array, and I could have iterated over that array and then done something with it, but this is what I did for now because we're kind of pushing through. We then set up the texture for each. We then create a vector to store all of them, and then we're going to place them inside of our balls. But the balls are going to use a different kind of sprite component. So we had just a general sprite component, which is just for drawing a texture onto the screen someplace. In this other one, we have an animated sprite component, which will loop through a vector of sprites, or textures, if you will, and it's going to decide which one to draw based upon how much time has passed. So here we create our ball right there. We create our animated sprite component, and then we go ahead and pass it its owner, which is the actor, as well as the draw order. I set its frames per second, and then I set the textures that it will then animate with. The last item is a new one, and that's the background. And this is going to utilize the BG Sprite component, or background sprite component. Same as before, pretty much. The only difference is that when it draws, it is going to decide what to draw from a vector of different textures. And it's going to slowly move these textures across the screen over time, so each one ends up having an offset associated with it. Load texture comes pretty much straight out of the book. We create a surface, we check to see that we were able to make that surface or access the texture that we're trying to create the surface with. We then convert it over into a texture object, which we use for drawing, and then we return that object. Setup texture is going to check to see whether or not a duplicate texture has already been created, because you might end up loading the same texture more than once. I didn't want to create a map with redundant textures, not that you can, because a map, everything's supposed to be unique, so it wouldn't occur, but I still wanted to go through and make sure that I wasn't adding anything that wasn't necessary at this time. So we do a check to make sure that it doesn't exist, and we will, of course, log an error if there is an issue and return nothing. Although now that I think about it, if it already existed, I should probably return the existing, return the existing texture, rather than just bail out of it, because you might want to use that thing instead of working with a null pointer. We go ahead and load the texture if we've gotten that far, if we haven't found it, and then we go ahead and store that away inside of our map for future use. I'm not at this time using the map, but it will become handy probably in the future at some point if we continue with these sprite-based games. So the add sprite function is kind of important. What we're going to do is we pass a pointer to the sprite that we've created, and we use its draw order as soon as we decide to add it to determine where within this vector it's going to be stored. We iterate over the entire thing until we find a spot where it is going to be greater than all of the elements before it. And then we go ahead and insert it. What has changed though, since the last video, is generate output. Before, generate output iterated over all the actors who implemented a method called draw. That's gone now. Instead, the components for sprites handle all the drawing. And that's why every single sprite, when it gets created, needs to give itself to the game to hold on to, so the game knows that the sprite exists and draws it at the appropriate time. In generate output now, we go ahead and set our background clear color. We then clear the screen using it, and then we iterate over every single sprite component, and we simply call its draw function. And then we swap the buffers when we're finished. Why don't we take a look at some of these component class elements? Component is pretty much like I showed before, but I didn't actually go into anything because I did everything actor-based, because we hadn't gotten to the second half of the chapter yet. We make sure that every component knows who its actor is so it can access important information. We also tell it what its update order is. By default, that's 100. We have an update function for this. By default, the component doesn't really care about this. It comes to those background and animated ones where getting that delta time is important, because you need to know when to swap a texture out or how much to offset a texture as it scrolls through the background. Looking at component CPP, we can see here that we go ahead and grab our owner, we set those variables. Now, very important is that we call the owner's add component method. This is something that I actually forgot for a moment when I was testing things, and I couldn't tell why nothing was updating on the component side. You have to add this, otherwise the actors will not have any components, and since we rely on the actors to update the components, an update will never occur. Now, the easier of the two classes is Sprite Component. So here, we're going to go ahead and inherit from component. We are going ahead and create our constructor and our deconstructor, all the same as before. Sprites are going to have draw orders, which you see here. We have a method to access that if necessary. We also have methods to access the width and the height of that texture. Sprite component, pretty easy here. The one thing that I will say that was added is the actor that owns this component. Of course, we can access the game object that gets passed to that using owner, then getGame, and now we can use addSprite. This system here means that I don't need to worry about making sure that game has a list of all of the sprites being used. This automatically, every time a sprite component gets created, will add it to that object. And since you're required to have an owner, this should be fine. The only thing that might be a little bit off is whether or not game exists. But because all of the actor code itself, the generation of actors now lives inside of game, a game has to exist to create an actor, and a component can only exist if an actor has been passed to it, a pointer. Therefore, this kind of makes sure we don't have any situations where game is null or owner is null. We then have the draw function, which is very simple. If we have a texture, because you could accidentally forget to set the texture, which can happen, so you need to call set texture before you do anything here, otherwise nothing's going to draw. We go ahead and create an Sdl Rect. The reason we use this is because we might have some scale offsets. We do have the ability to scale things up and down if we want to. We also have its position, but remember, right now the position of the object is in its center, and when we're drawing with a rect, we're actually in the upper left-hand corner. I believe that's correct for your perspective. We're then going to call Sdl render copy EX, which takes in the renderer, the texture, and several other things as well as a rotation to decide where to draw the object. So Sprite Component is pretty easy. We're just drawing a sprite or a texture to the surface. Animated Sprite and Background Sprite are going to build on top of this. So if we take a look at the header files really quickly, what we're going to see is we have this set animated textures, which is going to take in a vector of textures that we're going to iterate through to decide which one we're drawing at any particular time. Background Sprite Component is not so much different. We also take in the background textures. This is a vector of textures that we will then scroll slowly over time. Now in Animated Sprite Component, the big difference is our update function. But we go through and we check to see our size of our stack of textures or our vector of textures. And we're going to increment the current frame by the amount of time that has passed, which is why we need delta time, and multiply that by our frame rate, our frames per second. That's going to determine what frame we're currently at. We then decide which one of these we should then draw, and we set the texture equal to the one in that list that we want to draw with. Now this means we're relying on the functionality from the previous class, right? The fact that we set a specific texture to be drawn. Background Sprite is a little bit different. Inside of update for this, we're going to take in time, but we're going to use that time to offset each of these textures. So what you have to think about is that each one of these textures, when you load them down here in set background texture, so for every texture we have, it's going to put the first one here between the width 0 and the width of your screen. The second texture is going to get an offset equal to whatever that first width was. The third one would then get 2 times that width. So they're all stacked this way, and we're going to slowly scroll them by as time progresses. Why don't we go ahead and see what this looks like when we're all done. I'm going to hit Control and F5 to run. So here we can see our, oh, I just missed a bunch of balls. That's not good. Here we can see we have textures being drawn at the top and the bottom. We have a different texture for each of the paddles. We also have this lovely scrolling pattern in the background of the stars. And then our balls, in order to show off the animated texture, are doing this sort of pulsing thing because I use 3 different textures where each one gets successively smaller than the last one. Overall, doesn't look a whole lot different, but that was a lot of additional features and functionality to add to make this whole thing work. So why don't we talk about hangups that I personally had as I was coding this. Now it's been a little bit since I worked in C++. I think that's what I mentioned in the first video, is that a lot of me doing this was actually about relearning C++ because I was at one point going to dive back into the Unreal Engine. And so one thing that I struggled with for about 30 minutes was remembering the proper way of including things in that the order really matters. More importantly is the fact that you can include less in the header file and use things like class in order to forward declare that something exists without filling out all the details. And then in the CPP file, because you've gone through all these things, it's described all the classes, it knows how big everything is, then you can go ahead and pound include all manner of other things. I was running into conditions where I was trying to put everything here in the header file, all of my different headers for including. Don't need to do that, right? The basic game header only needs to know a few things. It's the actual CPP file for game that I needed to include a lot more, because as soon as I started using pointers to refer to things, especially down here, it needed to understand what those objects actually were before you were allowed to use pointers in this case. if you run into errors where your header files are all kinds of screwy and it doesn't know what an object is that you're trying to refer to, make sure you go through your header files and your CPP files and you only include exactly what you need. Another thing that really got to me was the fact that Sdl image is not part of Sdl, which the book didn't mention at all. So I had to go online and search for it. And then of course, once you do that, you had to download the different files. So in my case here, I have Sdl2_image 2.0.5, the includes and the library files. Once you do that, you also then need to go over to your project, right click, go into properties, and under properties, make sure you include under the VCC directories your new stuff. We already had Sdl, that was in the first video. Now we've got Sdl2 image that was added. And then you need to go under the linker, input, and add the library files for all of those as well. So chapter 2 took a little bit longer than I expected. There was a lot more that you have to fill in yourself than the book provides. I really do recommend if you run into any snags, you check out the GitHub repository. That's probably the fastest way to fix anything. I looked at it very quickly because I was running into issues where my header files were not in the right order. And then I remembered as soon as I saw the beginning of it that, oh crap, I can have a different set of includes for my headers than my CPP files. And then once I knew that, everything just fell right into place and there really wasn't any other problems. If you happen to be following along and tackling this chapter as well, why don't you let me know below how you're doing? See you all next time. So long and goodbye.